M-way search tree plus some rules is called as B-trees. Yes, M-way search tree with rules is called as B-tree. So now we will be going to talk about what is B-tree and what are the rules which are added to M-way search tree. Now let's see that. The first rule of B-tree is M-way search tree plus rules is equal to B-tree. Now the rules are what? I can construct M-way search tree with the first rule. Every node you have to fill at least half children. If you given with 4 keys, then at least 2 keys has to be present in the first node. Before this B-trees, if when you are talking about only M-way search tree, even singular node is also possible with single key. But whereas with the rules, when I am calling it is a B-tree, it is having some rules. The first rule is what? Every node we must fill at least half of the nodes, because to control the height of the tree. That is what the first point. The second point is what? Root. I am not applying this formula to root. Except of root, for all other nodes I am applying. That means root can have minimum of 2 children. And the third is all leaf nodes at same level. The fourth is creation process is bottom up approach. These are what rules which are applied on M-way search tree to get B-trees. Very simple. What is B-tree? B-tree which follows these rules. Right? Now we'll take some example. Let us construct a B-tree where M is equal to 4 and the keys are 10, 20, 40, 50. Now I am creating a node. So I am creating a node. My node is having 10, 20, 40, 50. As far as M-way search tree considered, when M is equal to 4, keys in the node should be M minus 1. That means you have here 4. So it should not be 4, it's only M minus 1, that is 4 minus 1 is equal to 3. So you have to split this node into 2 nodes. One node will be having 10, 20, 40. The other node will be having 50. So among these two only you have to choose root node. So I am just shifting the 40th place to root node. That means 40 over here, 10, 20 here and 50 here. So now let's see whether it is arranged in the ascending order or not. Now every element has to be, compare with the root element, you have to arrange the elements in such a way or elements of left side should be less than the root, elements of right side should be greater than the root. So this is about B-tree. If you wanted to construct any with the insertion part, if I wanted to insert, now let's see that I wanted to insert, and here you might have noticed that it is what bottom up approach, because from bottom we will be constructing, right? So we'll take the other example that I wanted to insert 16. Now where can I insert? Here I can insert, right? If I wanted to insert 70, where can I insert? Here I can insert. If I wanted to have 80, I'll be splitting the node and I'll be keeping here 80, right? So this is the way how your B-trees are existed in the data structure. Now we'll be going to talk about what are B plus trees. B plus trees are what? We will be having a record pointer from every node. So here as far as this B tree is considered, here you can see a record pointer to access your multi-indexing. Here also you can have a record pointer. For each and every element you will be having a record pointer to point out to which index it is pointing, to which index the data is pointing. So now B plus tree is what? B plus tree is having some difference that we'll draw and we'll discuss. Now let's see that now I'm adding B plus trees. What do you mean by B plus trees? We will have a record pointer only from the leaf nodes. Only from the leaf nodes. What? Record pointer. Now let's see that I wanted to construct a B plus. Now let's construct the B plus tree. Now I'm constructing the B plus tree. So let's see this example, that 40, 15, 20, 70. Now 15 lesser nodes will be at left side, 20 greater nodes at right side, 30, 35, and 70 greater nodes at those are what, 80, and lesser node is what, 50 and 60. Now let's assume this example. So here in this let's take this is 90 and 70. Now in this example, so you will be having a record pointer. If it is a B tree, you will be having a record pointer in each level of a node, whereas it is a B plus trees, now we will be having all the keys are present in leaf nodes, and in non-leaf nodes their duplicates may be present. That means 15, 20 will be here, and 70, 90 will be present over here. So here what happens is, you will be having a duplicate copy here, and this copy will be available over here. That means all these nodes are existed in the leaf nodes. All the keys are present in leaf nodes, and in non-leaf nodes their duplicates may be present. Every key must be present in leaf, and there are no record pointers from non-leaf nodes. Now, so we will be pointing to the multi-level indexing. Each key element will be pointing to the indexing from the database to access the data. So this is what B plus trees. So this is about B trees and B plus trees. Complete information about B and B plus trees, how it works with data structures, how database is associated with this data structure. Thank you all.